Okay, on this question, we want to find the derivative of f of x equals x squared plus 3 to the 5th power plus x all raised to the 2nd power. So we're going to use the chain rule on this because we have an inside function and an outside function. We're going to follow the rule for the outside function first. So to do that, the outside function is a squared, so we're going to use the power rule. We'll bring that power down, and we'll take 1 away from the power. But then to use the chain rule, we want to leave the inside the same. And then multiply by the derivative of the inside. So we want to multiply by the derivative of the inside. So we've got 2 times x squared plus 3 to the 5th plus x to the 1st power. We don't need to write that 1. And now we want to take the derivative of this other expression. And when I'm looking inside, I've got 2 separate terms because of this plus sign. So I can take the derivative of those individually. The derivative of x is 1, so that's simple. But then on this other part, we once again have to use the chain rule because we have an inside function and an outside function. So we want to follow the derivative for the outside function, which would be the power rule. So we bring the power down, take 1 away from the power. I've left the inside the same, and I have to chain by multiplying by the derivative of the inside. I carried that plus down. So this would give me 2 times x squared plus 3 to the 5th plus x, 5 times x squared plus 3 to the 4th, and I'm calculating the derivative on this part here. That's the derivative of x squared is 2x. And I've got a little simplification I can do. I can multiply these two together. That would give me 10x times x squared plus 3 to the 4th plus 1. And I'd probably leave it like that as the derivative. I want to find the derivative of this equation y equals cotangent cubed square root x. And the first thing I'm going to do is rewrite this as cotangent of x to the 1/2 power, and then move that cube to the outside. This is going to help me identify how to use the chain rule properly. Now I have on the outside the cube, and so I'll start calculating the derivative with the power rule because of it. So I bring the power down. I'm going to take 1 away from the power. That's using the power rule. Then I'm going to leave the inside alone and chain by multiplying by the derivative of the inside. So then I have 3 cotangent squared x to the 1/2. And I need to take the derivative of cotangent of x to the 1/2. So for this, I have cotangent on the outside and x to the 1/2 on the inside. So I'm going to follow my derivative rule for cotangent, and the derivative of cotangent is negative cosecant. So this is times negative cosecant squared. And I'm going to chain it. I'm going to leave the inside alone and chain it by multiplying by the derivative of the inside. So this now gives me -3 cotangent squared x to the 1/2 times cosecant squared x to the 1/2. I need to calculate the derivative of x to the 1/2. There I'll use the power rule. Bring the power down and take 1 away from the power, giving me -1/2. And I think maybe the last thing I'll do is to move the 2 to the denominator and move this whole factor to the denominator because it has a negative exponent. So this would give me -3 cotangent squared. I can turn that back to a square root. Cosecant squared, turn that back to a square root. And then I have that 2 square root of x in the denominator. And so I've got the derivative being -3 cotangent squared square root x cosecant squared square root x over 2 square root x. So I have d dx, which is find the derivative of what's inside the brackets with respect to x. I want to calculate the derivative on this, and I notice that I have a natural log on the outside, and then I also have an expression inside the log. And what's inside that natural log is something other than x. And so I know I need to use the chain rule to be able to calculate this derivative. So you're going to start by following the rule for the most outside function, which in this case is natural log. So the rule that we're going to be following is the derivative of natural log x is 1 over x. Or if you want to use the rule that has the chain rule built in, that would be natural log u, which is u prime over u. So with the chain rule built in, all of this would be our u. So that's what we would put in our denominator. And then in the numerator, we want to calculate the derivative of that. So I'm going to calculate the derivative of that numerator. But once again, we notice that we have an outside function and an inside function. So once again, I'm going to have to use the chain rule on that. And my outside function is the rule that I follow. So my outside function is the natural log. So I'll do u prime x squared, the derivative of x squared, over u. The derivative of x squared is 2x. And then I can rewrite this as 2x over x squared natural log x squared. So basically I'm taking this fraction and moving it down to the denominator. So I got the derivative of natural log x squared to be 2x over x squared natural log x squared, and this I can simplify more. I've got a factor of x on both the numerator and denominator, so I can write this as 2 over x natural log x squared. I want to find d dx. That's the derivative with respect to x, so we're taking the derivative of what's inside the brackets. And on this example, I need to use the chain rule. And our most outside function is this squared. So that's the rule I'm going to follow first. So we're going to take that power down and take 1 away from the power. We're going to leave the inside alone and multiply by the derivative of the inside. So this gives me 2 natural log of natural log x times, and I'm going to take the derivative of natural log x. And I have, once again, an outside function and an inside function. And I'll follow the rule for the outside function, which is the natural log. So I'm following the rule. Natural log u, the derivative of natural log u is u prime over u, which is the derivative of the inside over the inside. So I need to do the derivative of the inside over the inside. The derivative of natural log is 1 over x. And then I can write this as 2 natural log of natural log x. So all of this is staying in the numerator. This 1 would stay in the numerator. And then I'm going to send this x to the denominator and write x natural log x. I've got 2 natural log of natural log x over x natural log x.